Welcome to The Explainer. Okay, let's talk about one of the most common materials on Earth, concrete. Today, we're digging into its story and how its ancient past might, believe it or not, be the key to our sustainable future.
So let's just jump right into the big question, the central paradox we're looking at today. I mean, you've got modern structures that can start falling apart in just a few decades. And then you have these ancient Roman marvels that have weathered millennia. What did they know that we've somehow forgotten?
To really get a handle on why this ancient secret matters so much right now, we've got to talk about the huge problems with the concrete we use today. And it's not just that it doesn't last, it's about the health of our planet. Let's start with this number, 8%. That's how much of global CO2 emissions comes from making cement, which is, the key glue that holds our modern concrete together. To put that in perspective, that's more than the entire aviation industry. It's a staggering figure. And you might be asking, where does all that CO2 come from? Well, it's actually a bit of a double whammy. First, you have to burn an immense amount of fossil fuels to get limestone hot enough in these giant kilns. And second, the chemical reaction of heating the limestone itself, well, that releases a massive amount of CO2 directly into the air. And that brings us to the other big problem. Our concrete just doesn't last. A typical modern building, if it's well made and you take care of it, might last 50, maybe 100 years. This short lifespan means we're constantly in this cycle of tearing things down and rebuilding, which of course means making more cement and pumping out even more emissions. So, why does our concrete fail? You'd think it's rock solid, right? But it's actually got a few Achilles heels. The biggest culprit a lot of the time is the steel rebar we put inside it. As soon as moisture seeps in, that steel starts to rust. And when it rusts, it expands, creating this incredible internal pressure that literally cracks the concrete from the inside out. Throw in damage from freezing and thawing, de-icing salts on our roads, and you've got a recipe for things falling apart way too soon. Okay, so with all that in mind, let's go back in time. How on earth did the Romans build things that seem almost immortal compared to what we build today? Well, the Romans had their own special formula. It's called opus caementitium, and right off the bat, you see these two ingredients that would make a modern engineer just cringe: volcanic ash and seawater. We spend so much effort trying to keep salt out of our concrete because it destroys the rebar, and yet the Romans were using it on purpose. But this is where it gets really mind-blowing. Our concrete starts degrading pretty much the day we pour it. But Roman structures that were built in the sea, like piers and breakwaters, they actually got stronger over time. Being constantly pounded by corrosive seawater didn't weaken them, it made them tougher. How is that possible? So what's the secret? What's the magic ingredient? For the longest time, nobody knew. But we're finally cracking the code, and it all comes down to one amazing property: self-healing. It turns out it wasn't just what they used, but how they mixed it. They used something called hot mixing. Instead of using a pre-mixed hydrated lime like we do, they threw in quicklime, which is calcium oxide. And that process created this intense heat, which completely changed the chemistry of the concrete. This hot mixing process was so intense that it left behind these little white, brittle chunks of lime scattered throughout the concrete. For years, scientists saw these lime clasts and just figured, sloppy mixing. But it turns out, those little imperfections are the absolute key to everything. They're the secret weapon. Okay, so here's how this genius built-in repair system works. A tiny crack forms in the concrete. Water gets in, but then that water hits one of these lime clasts and activates it. It kicks off a chemical reaction that grows new calcium minerals that recrystallize and completely fill the gap. It literally heals itself, stopping a tiny crack from ever becoming a big problem. And it gets even better. The concrete didn't just patch itself. In places like harbors, the constant flow of seawater kept reacting with that volcanic ash, forming these rare, super strong interlocking crystals. So the material was actively reinforcing itself, getting tougher and tougher over centuries. Okay, so that's all fascinating history, but what does it mean for us today? Can we actually use this ancient wisdom to fix our modern infrastructure crisis? Well, it's looking more and more like the answer is yes. Right, so remember the biggest weak point in our concrete? That steel rebar. Not only does it rust, but it also expands and contracts from heat and cold at a totally different rate than the concrete around it, which creates constant stress and microcracking. So what are we trying to do about it now? Well, engineers are playing with all sorts of alternatives.
You've got things like epoxy-coated steel, which helps a bit, but the coating can get nicked. You've got stainless steel, which is great, but crazy expensive. And even things like glass fiber composites. But as you can see, each one has its own pretty big downsides. But the really exciting stuff, the real game changer, is when we stop just trying to put a Band-Aid on the old system and start truly mimicking the Romans. That means using industrial byproducts like fly ash to cut down on cement, developing additives that literally grow waterproofing crystals inside the concrete, and, this is the coolest part, researching brand new formulas that can actually self-heal, just like the Roman originals. And that brings us right back to the main takeaway. It's this one pretty wild idea. Could the answer to one of our biggest modern challenges, building a sustainable future, be hidden in something the Romans figured out 2,000 years ago? Maybe the most innovative thing we can do is look back.